Hello students, in the previous class we have studied about elasticity and stress and strain, and here in this video we will be studying about the relation between stress and strain. But before that we have to understand a term called elastic limit. So what is elastic limit? Let us consider we have a rubber band. Okay, let us consider we have a rubber band and we try to deform the shape of the rubber band. We are applying, let us consider we apply 1 Newton of force, and when we remove the force, the rubber band comes to its original position. We apply, let us consider after 1 Newton we are applying 2 Newton of force, and then again when we are removing the force, it is coming again to its original position. Let us consider at a point of time we are applying 3 Newton of force. Again when we are removing the force, the rubber band is coming to its original position. But after this 3 Newton, when we are increasing the amount of force, the rubber band breaks. And the point where the rubber band breaks, let us consider when we are applying the 4 Newton of force, the rubber band is breaking, and due to the break, the rubber band will not be able to regain its original shape. So, what is elastic limit? So, we can define it in two ways. So, this is the point, that is 3 Newton of force. Up to 3 Newton of force, the rubber band was able to regain its original position, and after 3 Newton force, when we are applying any amount of force, the rubber band was not able to regain its original position. So this 3 Newton is the limit. Limit of what? Limit of elasticity of that rubber band. So elastic limit of any material can be defined in two ways. If we see the right side of this is the minimum value. This is the minimum value after which the rubber band will not be able to regain its original shape. Minimum value means if we increase the value of applied force, that is the deforming force above 3 Newton, we will see that the rubber band will not be able to regain its original shape. So this is the minimum value if we see the right hand side. If we see the left hand side, then this is the maximum value. Among 1 Newton, 2 Newton and 3 Newton, this is the maximum value. So we can define elastic limit first. If we see the right hand side, then this is the minimum value. This is the minimum value. And if we see the right hand side, then this is the maximum value. Maximum value of what? This is 3 Newton is the maximum value up to which the rubber band is showing its elastic characteristics. Elastic characteristic. And that is why we say this 3 Newton is the elastic limit of that rubber band. So what is elastic limit? The minimum value of increasing stress. Increasing stress after which means if we increase the force, the rubber band or the material will not be able to regain its original configuration. And also it can also be defined from the left hand side of this limit. We can also define it as this is the maximum value of deforming force up to which the object will be able to regain its original shape or the elastic characteristic. So this is what elastic limit is that we had to understand. After that, we have a new topic called Hooke's law. From here, we will start to understand the relation between stress and strain. So this is the elastic limit. This is the elastic limit of the object. So within this limit, Hooke's law states that within the elastic limit, stress applied on any object is directly proportional to strain created on that object. When we remove this proportionality sign, we can put a constant over here. Therefore, we get stress is equals to constant multiplied by strain. So finally, we get this constant is equals to stress divided by strain, where this K is known as the constant and also is known as Hooke's constant, or we can simply say it as modulus of elasticity. So in the previous video, we have studied about 3 types of stress and strain. Simultaneously, we have studied longitudinal tensile stress, longitudinal strain, volumetric stress, volumetric strain, shearing stress, shearing strain. And here also we will discuss about modulus of elasticity with this relation stress upon strain of all the three types of elasticity.